So today we're going to be covering a brief introduction to Chameleon. We'll cover what Chameleon is, how you can use it, and examples of research that's being conducted on the testbed. I'll also tell you some tips and tricks that might be not as well known, but which are very useful as you begin experimenting. And like I said before, Adam is on the line. If you have any questions, feel free to pop them in chat and we'll get you the answer. And if something comes up afterwards, after this webinar that you didn't get a chance to ask, feel free to reach out to the Chameleon help desk. It has a really fast turnaround, usually within a couple hours, but maximum maybe in a day or so. But without further ado, let's begin. So what is Chameleon? Chameleon is a cloud testbed that gives you access to high performance resources. It's similar to AWS, Google Cloud, Azure, Cloud Lab, or Jetstream, if you've used any of those before. But our operating interface might be slightly different from what you're used to. And most importantly, we provide access to our resources at no cost to the users because the NSF is funding Chameleon. And let's begin with what might possibly be the most relevant for you. What resources do we have and what you can do with them? So as you can see by this slide, Chameleon has a wide variety of hardware, storage, and networking capabilities with CPU, GPU, FPGA, and networking options. You can reserve any of these resources and use multiple of these resources at any given time. We've also just added an edge testbed in the past year. So we have some Raspberry Pis and Jetson Nanos available so you can experiment with edge to cloud computing. And we're always adding more. So if there's any specific resource or device that would be useful for your research, just send us a note and we'll see about if we can collaborate to get that for you. The link on the screen there, chameleoncloud.org/hardware, will take you to our hardware browser, where you'll be able to explore all of the resources that we have, as well as hardware specifics, such as the model or the clock speed, as well as filter for specific criteria. And we'll poke around that web page in a little bit as well, so you'll get more familiar with it. And then to give you an example of what you can do on Chameleon, I'll briefly introduce some of the past research that users have conducted on Chameleon. And you can learn more about each of these stories on the Chameleon blog as well. So our first example is using the Chameleon Edge Computing platform to design and deploy the future of agriculture. Oh yeah, I see Lily raised their hand. Let me see, Lily, if you want to, I think you might be able to unmute yourself. Or was that, I see you put your hand down, was that a mistake? If so, you can just put that in the chat as well. Yes, if you have a question, put it in the chat. If it was a mistake, don't worry. But so Ara is the user that is using Chameleon to design the future of agriculture. It's based at the Iowa State University and it's deployed across rural Iowa as well. And they're working to deploy advanced wireless access for agricultural and educational purposes. So some examples of the things they will support include precision agriculture, crop phenotyping, precision livestock farming, and agriculture automation, such as the drones and automated ground vehicles that you can see in these photos. You can see also a diagram of the infrastructure they're building around the photo. And the vehicles you see in the photos record the data and send it back to the cloud. And so the idea is that they're going to be using Chameleon's edge testbed for some of these edge nodes and for baseline support to help farmers and then other livestock farmers, agricultural farmers, maximize using all of the machine learning and other wireless resources to design the future of agriculture. And then the next resource or user research that we have is research conducted at the University of Missouri, and they're using the testbed to train machine learning models. So these researchers are trying to prevent facial authentication attacks. And so first they attempted to be the attacker, and then they designed a neural network that can classify whether a user's facial authentication data had been poisoned or not. So these experiments required several terabytes of data and then storage of the model on Chameleon. And so they used one of Chameleon's capabilities called CC Snapshot, which lets you save your work even if your reservation of the hardware is expiring. So it's basically like a control S for your experiment. And there is a webinar later this afternoon that will cover this capability more in depth, but it's a very handy tool. So you don't have to restart all of your work. And I highly recommend looking into it. There's more about it in the documentation as well. And for these users, the cost would have been prohibitive to run a machine learning experiment this large or with this much data on the university resources. And so that is where Chameleon came in. The next user research is somewhat similar. They also used it for facial authentication, but they focused on biometric research. And so to identify between real and spoofed faces. And so you can see in the photo below, faces number 1 and 4 are the real faces, while faces 2 and 3 are the spoofed faces. One is a 3D printed face and the other is a photograph. And so they built a model to, or they trained a model to recognize between these real and spoofed faces. And if these researchers were able to spread the model across multiple GPUs, and if they'd only had access to one GPU, it would have been kind of logistically and financially difficult to build and train this model. And these researchers in particular have made their pipeline and model available to other researchers on Chameleon to use and experiment with. And so if you're interested in this, you can find more of an explanation and a link at the bottom of their blog if you're interested. Alternatively, if you just Google biometric research in the cloud and Chameleon Cloud, it'll pop up. And then finally, another really exciting use of Chameleon was at the supercomputing conference last year. So every year they have a student cluster competition, or SCC, where teams of undergraduate students compete to build a cluster and run a test application on it with a certain power cap. And so in the past, this was limited to universities that already had the resources on site for students to use. But last year, Indie SCC was created, which is a virtual version of the student cluster competition, with students using Chameleon resources to compete. Some P100 GPUs and an ARM node were used. And so this opened up the competition to new schools and reduced barriers by providing access to cloud computing resources. And so what you see here is a power monitoring dashboard that kept track of each team's power usage, so both judges and teams could keep track of their progress. I'm so sorry, I'm gonna run and grab some water because my throat got a little scratchy, so I'll be right back. You guys can look at the power dashboard 1 sec. Okay, so now coming back to this slide, since you're a little bit more familiar with Chameleon and what it can be used for, similar again to AWS and Azure, and that we provide resources to users. We don't have as many resources as they do. So we have a reservation system, which will be a new concept. It's also similar to Cloud Lab, if you've used that before, but probably the main difference is navigating a commodity cloud interface and assembling things on the fly. And we're funded by NSF. So you're able to run these experiments on these resources without paying to use them as you would on AWS or Azure. And as you've seen with the examples, you can run experiments with lots of data. You own the bare metal node, so it's deeply programmable and reconfigurable. It's also completely isolated. So you can power it on and off, reboot. This is your node, you're not sharing it with any other users. And we've also designed the platform to be open and collaborative. You can share your experiments as you would in Google Drive or Overleaf. sharing them with individuals within the project you're working on or publicly. You can also publish these experiments to Zenodo, where you'll receive a DOI to include in your paper or posters. And then we also have something called Trovy, which is the Chameleon sharing platform. And so I'll go into this in a little bit more depth later on. And finally, we have something called DayPass, which lets non-Chameleon users run an experiment that somebody has created or enabled the DayPass for. And so this is helpful if you include a link or a QR code to your experiment in a paper or poster and a stranger is interested in it or reading it on the ether, they can request a DayPass for Chameleon to run the experiment without having to be part of a project. And finally, it's large scale and diverse. You saw that in terms of hardware, but here's a little bit more information about what's going on behind the scenes. So we currently have over 4,700 users from 160 institutions and 45 countries with over 800 projects now. And there are 571 nodes across 2 of our original sites, which are hosted at UChicago and TAC. And in the past year, we've added 3 new sites at Northwestern University, at NCAR, which is the National Center for Atmospheric Research, and at EVL, or the Electronic Visualization Lab at the University of Illinois Urbana-Champaign. And the resources vary across each of these sites. So for example, NCAR has ARM ThunderX2 nodes, which were used at the supercomputing conference that I mentioned before, while EVL has Hazel nodes. But with a Chameleon account, you can access and experiment with any of these resources from the comfort of your home. So now you might be thinking, this sounds great, but how do I get started? So we do have some requirements for you to begin using these resources, and I'll just go over them briefly so there's no confusion there. So here are a couple of common terms that you'll see: the project, an allocation, and PI. So to use Chameleon resources, you have to apply for a Chameleon project. When you apply for a project, you'll include a brief description of your research and the resources that you anticipate using. And then when and if you're approved, you'll receive an allocation for an initial amount of service units, or SUs, for a period of 6 months. And so a more detailed description of this process and service units and other concepts can be found in the Chameleon FAQs, or frequently asked questions, which is on the website. But essentially, every time we use a Chameleon resource, your allocation will be using these service units. And then if you run out of these service units, you can always apply for more. And then if your research continues after these 6 months, you can apply to renew your project. So you may run out, you may need to continue, but you can always apply for more for continued use of the platform. And then to apply for a project and allocation, you need to be a PI. So what is a PI? So a PI is the head of a Chameleon project. To be a PI, you need to be a US-based researcher at an academic institution or a federal agency, such as a national lab. There are a couple other possible eligible categories, such as like independent researchers or NSF graduate student fellows. But more details about each of these can be seen, again, in the Chameleon frequently asked questions. International researchers are welcome to apply as well, as long as you're collaborating with a US-based project. But if there are any questions regarding your eligibility or anything like that, you can always reach out to us at contact@chameleoncloud.org and send us an email there. But so only PIs can apply for this bigger, larger project concept. But if you're not PI eligible, so for example, you're an undergraduate student who wants to conduct research on Chameleon, you would have your professor apply for a project. And then they can add you as a user. And once you're a user on a project that has an active allocation, so you have SUs to use, you can use any of the Chameleon resources. So it's a pretty seamless, easy process. But that's kind of how it works. And so to get started using the Chameleon resources, once you have access to them, we have 3 different interfaces that you can interact with: the GUI, in Jupyter, and then the command line. And you're not just limited to one of these. You can use all of them. You can only use one of them. You can switch between them at different points of your time with Chameleon, or even during an experiment. Some of these might be more useful for different scenarios. So the command line is useful potentially for debugging, whereas Jupyter, because you can mix code and text, it can be useful for reproducibility and for packaging experiments in that way. So first off, we have the GUI, or the graphical user interface, which is what you see when you log on to Chameleon and access a site like Chi@UC. So I'll just show you what that looks like. So when you log on to Chameleon, or when you go to chameleoncloud.org, you will see this website here. This is not the experimental portal, so you won't be able to see any of your instances or reservations or things like that. You have to navigate to experiment and then click on one of these sites. And this will take you to the experimental platform. And this is where you can reserve resources and start running your experiments. And so that'll be what it looks like here. And then the second option is the Jupyter interface. You navigate to that by, once you're on the home screen, you go to experiment and you hit Jupyter interface. And that'll take you on to being able to run the experiments on Jupyter. And it runs with something called Python Chi, which is something you might have seen mentioned in monthly Chameleon updates, the changelog. And this is how we interact with the Chameleon infrastructure itself. And so once you're in the Jupyter interface, you can run experiments as you would normally in a Jupyter notebook, but also reserve resources on Chameleon. And then finally, the other interface you'll be able to use when interacting with Chameleon is the command line interface. And so I recommend going to the documentation. To get to there, you navigate by going to Learn and then clicking Documentation, and it will take you to this page. You can see there's a very thorough documentation for each of the testbed interfaces, and so you can learn how to install and authenticate with the command line and begin experimenting with that. I highly recommend following the steps in the documentation as you're setting things up, and going to the documentation first if you have any questions. It's very thorough. It's likely your question is answered here, so definitely check here before submitting a help desk ticket. And another great thing about the documentation is that you can search within the documentation here, or you can even Google something. So if you were to Google launching an instance Chameleon, the relevant page would pop right up. And then going back to the presentation, the next step, now that you know how to interact with the testbed, we're going to talk about experimenting on Chameleon. So this is kind of a general experimental workflow. You begin, of course, by designing your experiment, what you want to run. And then you'll discover, we call it discover your resources. And so that's the hardware catalog that I mentioned earlier, and we'll take a look at now. So you'll be able to pick and choose which resources you want to run your experiment on. Next, you'll provision your resources, configure and interact with them, and monitor them. So this is just the step of reserving the resources on Chameleon, launching an instance, running your experiment. And then finally, when the experimental results come out, you'll analyze, discuss, and share them. And so I'll go over each of these steps in more detail, but an important note, as you see in red, is at the very end, once your experiment has finished running, is to make sure to tear it down. This is a crucial step because we are not as large as Amazon or Microsoft, so we have a limited amount of resources. And so by terminating your reservation, once you finish your experiment, this then frees up the resource for other users. And if you need to rerun the experiment, you can just make another reservation, even for the exact same resource, and run it again on there. So as I mentioned, the first step is to discover resources. And And so, as I said before, Chameleon maintains a catalog of the different hardware that we have. And so if you go to chameleoncloud.org/hardware, you can see the different types of hardware, even down to the location of the nodes and the racks, which could be useful if you're doing an experiment where proximity is important, or if there's a specific node that you would like to reserve. So to find that, as I mentioned before, you go to experiment, hardware discovery, and then it might take a minute to load, but once it does, you'll be able to see all of the resources that we have available. And so some of these are coded names, so compute Cascade Lake or compute Skylake. And so these are just Intel CPUs, whereas others like GPU K80 is the specific K80 GPU. So some of them are self-explanatory, others are just are less obvious. And if you want to know more about a specific resource, you can Google it, and the hardware specifics are available, on the Intel website. But if you select a specific resource, so like if I selected the GPU V100s and I viewed them, I would be able to see like RAM size and like clock speed and other information about each of the GPUs, as well as the location within the larger Chameleon platform. So after you've decided on what resource you would like to use, you're going to reserve it. This is different than AWS or Azure, as I mentioned before, because we have a limited amount of resources and you're getting the whole machine. You're not sharing it with anybody. And so when you reserve a resource and it's reserved for you and only you, which is why it's important to release it when you're done with it. And so there are two types of resources or reservations: on demand and in advance. If you're using a reservation that's popular, we recommend creating a reservation in advance, just to make sure that you have access to it when you want it. But so when you make a reservation, you can either create it for now, which is the on-demand kind, or for a specific date and time in the future, which is the in advance kind. And we do have a 7-day limit on the reservations, just to make sure that all users are able to have a chance to access the resources. But you're able to create another reservation for the same resource if you still need it after the 7 days are up. And when your reservation lease runs out, it's important to know that your experimental environment will be automatically torn down. So there won't be anything saved if you come back to that node in the future and create a reservation on it. So this is why the CC snapshot capability, which I mentioned earlier, is important, because it essentially saves your work, and then you can use that snapshot when you create a new reservation. You can also back up your data via the object store. And all of this, if you go to the webinar today at 3 p.m. Central Time, will be explained in more depth. And then, as I mentioned before, the in advance reservation can be very helpful if you're using a resource which is in high demand, like the GPUs. And so you can reserve it far ahead of time if you know that you're going to need a specific resource, just to make sure it's available for when you need it. So the very first thing you need to do to begin reserving a resource is to log in. There are multiple sites that you can log into. So for example, you see here, it says chi.uc.chameleoncloud.org. And so this is for the UC sites, but you could replace that with TAC or EVL. Once you log in, it doesn't matter. You can switch between these sites, so you can change your mind. After logging in, this is the overview that you'll see, which I showed earlier. And so as I mentioned here, you can switch between the sites by clicking on any of these. And if you're a part of multiple projects, you would switch between those here. And so that just makes sure that you're charging the SUs to the project that you're doing the experiments on. Okay, so yes, I explained that. So there you can see the different projects and the sites. So to make a reservation, you go down to the reservations and you click on leases. And so here you see that there are 2 leases that are in active or in process. You might not have any at all if this is your first time. But in either case, if you wanted to create a new one, you would click the create lease blue box. And as I mentioned before, the maximum amount of time you can create a lease for is 7 days, but you can renew it after that. So when you create a lease, click create a lease, you'll see this pop up. This slide can be very overwhelming, but don't worry. All you need to pay attention to is everything with an asterisk. Everything else is, you can modify it if you want, otherwise just ignore it. But you'll need to create the lease name, and then choose a start date, start time, which is larger over here. So this is where you would adjust it if you wanted to create a reservation in advance. And then you would choose down here, when you choose your node type, you could change this to a GPU or a different, whatever resource you're interested in. And then we also recommend reserving a floating IP here as well. And so a floating IP is just, it's the way that you interact and connect with your experiment from the outside. It's just a public IP kind of thing. And you only ever need one. It has the option to add multiple there, but you only ever need one, regardless of how many resources you're using. And Chameleon has a finite number of IP addresses. So please don't just assign them randomly. And then once you have set everything here, you click create, and your lease will begin. After that, you'll see here, as it is here, it says pending. And so the next step here actually is you'll see right here, the arrow points to something called the host calendar. And so this will make your life a lot easier when it comes to obtaining the resources that you want. Clicking this, it can take a minute to load, but once it does, you'll see when specific nodes are reserved. And so if I go to that here, reservations, leases, host calendar. So this will be specific to the Chia tax site. And so it will show each of the resources that are on the tax site and when they're reserved. And so if you were interested in a specific node and it was in use, you will see here, if I wanted this node, I can't reserve it because it's in use right now. However, I could go down and choose to reserve this node. And so this can help you on the previous screen kind of make sure to be able to choose a node that is available right now. And then for planning reservations in advance, you can also see when the next reservation will terminate. And so you can plan, if you scroll down to the bottom, it'll say like with a time and date. And so you could plan to reserve it after June 11th if you were interested in this node. But this might not be an issue if you're using it on a less popular resource. It's usually just with GPUs that you might run into some trouble getting the time on there. But this is very helpful in that it lets you maximize your work time and plan when you're going to be running experiments. So the next step after reserving your resources is to configure and interact with it. And so this is where we'll be covering how to deploy a bare metal image, assign a public IP, and access your instance. So the very first thing that you need to do is create a key pair so that you can be able to securely access your instance. To do this, on the side tab that you see on the previous page, you go down to compute and key pairs. And so once you click on this, you can either generate a new one, so create key pair, or you can import a public key if you already have one on your laptop. This is very simple. If you're just creating one, you just choose a name and hit generate. And then the next step is to choose an image. And so here, you just go up one from the key pairs, it'll be images. And later this afternoon at 3 p.m. Central Time, again, as part of the same webinar I mentioned earlier, we'll have something, we'll cover a little bit more in depth what images are available for you to use. But the basics is that the images that you see here are all available. If you see a little Chameleon logo next to it, that means it's maintained by the Chameleon team. But Chameleon users can also post their own images. And so as I mentioned earlier, the users who had 3D printed the face masks created their own pipeline and image, which other Chameleon users can launch. So if you were interested in trying that out, you could choose that here. And so there are, we recommend just using one of these pre-built images. Usually we recommend the Chameleon ones, just so you know it's secure as well and maintained. And then you just hit launch image once you've chosen that. And so when you go to launch an instance, this is what you'll see. And so we require that you give it a name. We recommend that you add your username as the very first thing, because on that on the main page, if you're part of a project with multiple users, every user will be able to see all of the instances and reservations that are associated with that project. So if you're, say, for example, in a class or with other colleagues, and they see there's an instance or a reservation which is generic, and maybe they'll think that nobody's using it, they might accidentally delete it. And so it's good practice just to put your name on there, so they know that that's what you're using, and there's no chance of accidentally deleting it, we hope. And then we also recommend that you add the experiment name to the instance as well. So, and this is just for you as you use it, in case you're running several different experiments, you're able to keep track of which instance is part of, is used for that experiment. And depending on if you've used this before, you'll select the reservation, and so that'll be the reservation that we just created. You can attach a network to it. The shared net, which you'll see if you click on networks, is just the network that's shared by all Chameleon users and is a good default. And then you'll also want to go down to key pair and add the key pair that we created or that you uploaded earlier. And after setting all of those parameters, you hit launch instance. It will take about 5 to 10 minutes to spin up and finish launching, to just make sure all of your parameters are configured the way that you want. So don't be worried, don't be concerned if after 5 minutes it's still not saying active. It'll take 5 to 10 minutes. Afterwards, you'll associate a floating IP, the same one that we reserved earlier. And so you'll allocate that IP to your instance that you just created. And it's very simple. You go to the network tab, floating IPs, and then you'll associate it with the instance. You'll click associate and associate it with the instance that you just launched. And when you're in those 5 to 10 minutes, when you're not sure if the instance has completed the launching process yet, you can go to the compute tab and see the status of your instance. And so once the status goes to running, that means that it's up and ready and ready for you to experiment with. And so once it's ready, you can SSH into your instance with the following command. And so you would just replace the key file with yours and the floating IP with the floating IP that you associated in the previous step. Some people run into a little bit of issues here if they're not as familiar with SSH. So there's a link to a troubleshooting guide right there. And if you try this out in the future and run into any issues, highly recommend checking that out first. So now that you are familiar with reserving resources, launching an instance, and accessing the instance to begin experimenting, we can now explore what happens once you've finished experimenting and how you can share your projects, your experiments with others, and then just explore some other tips and tricks that might come in handy as you begin experimenting. So this is the appliance catalog. It's available at chameleoncloud.org/appliances. I mentioned this, or I touched on this kind of briefly before, but this is where all of the images are housed. You can search for them by name, description, or author. These are all of the images that are maintained by the Chameleon team. Again, if you see the little chameleon, or created by other users. And so you can see here, there's like a Clarkson some neural network TensorFlow options as well. So if you were interested in trying out a different image, you can explore images within the appliance catalog. And so you should be able to find the biometric one if you search for that in here as well. But he also has a link at the end of his blog that leads you directly to it. The next thing I want to talk about is Trovy, and this is specifically for sharing. Trovy is Chameleon's sharing platform. You can think of it like a Google Drive. It's where experiments that are designed to run on Chameleon are packaged end-to-end in Jupyter notebooks. And so if you're unfamiliar with Jupyter, we have a webinar coming up tomorrow, specifically on this topic. At the end of this, I'll have a slide with all the webinars coming up in the future. So you can look at that then, and I highly recommend attending that webinar if you're at all interested in learning a little bit more about Jupyter or using Chameleon to package experiments for reproducibility, or possibly sharing it in a paper or a poster. We also have tutorials on the Chameleon YouTube channel, which will explain Trovy in a little bit more depth as well. But once you are on Trovy, which you navigate to by going to experiment and clicking Trovy, you'll see experiments that are publicly available or part of your library. And so here you can see this is the all view, but if you can share experiments publicly or keep them private within your library or within a team. And so this is a specific project, Chameleon reproducibility research. And so you can create experiments that are shared within your project in case collaborators or coworkers or colleagues want to experiment with it as well. If you're just getting started with Chameleon, I highly recommend starting to run some experiments using the Jupyter interface. I found it's just kind of the easiest way to get started, and you can rerun some of these Trovy experiments. If you click on one such as like the network and network experiment, you can then click launch and it'll launch itself on the Jupyter interface. Everything is already packaged in there and you can just run through the cells and become familiar with reserving resources on Chameleon and interacting with the Jupyter interface. So I believe I have the network and network experiment up. Yes, so this is what it should look like. You can see there's a little bit of text. This is kind of how we recommend packaging an experiment for reproducibility. I won't go too in depth into this right now since the webinar tomorrow will cover it. But just so you get an idea, there's a little bit of text about the experiment, requirements, and estimated time of how long it might take you to run this experiment. And then it's structured by having an experimental container section, an experiment section, and then a visualization section. And so here you can see this is the code that will begin reserving resources on Chameleon and launching instances. It is housed in separate scripts, which you can copy actually. So if you're interested in running an experiment on the Jupyter interface, just so you don't have to reinvent the wheel, I recommend looking at one of the experiments on Trovy and seeing if it is similar to what you're interested in. And then you can copy like the reservation scripts, which you can just use to create a reservation. And then you can, for example, just change what device you want to be using. And then you'll see like configuring the instance. And then when you get to the point of running an experiment, this we house within a Python script. And so you can see here that there's some of the general machine learning experiment structure that you would see in a machine learning experiment. And so once you run the experiment, you'll download the results, and then you can create a separate notebook to analyze and visualize these results, which is, again, unique to Jupyter, and that you can have text, code, and visualizations all in one spot. And it looks like these cells are, oh yeah, here's a cell that has the visualization run. And so if you're interested in using Jupyter, you can try running this yourself, and going over to Trophy and exploring some of the other experiments that you have there. This is also very helpful. There's kind of very general machine learning experiments as well, so like an MNIST TensorFlow experiment, which could be useful if you have students, as a way to familiarize them with Chameleon and general machine learning concepts as well. And yeah, so again, my main tip from this is that you can reuse and repurpose the scripts that I showed you previously, such as creating reservation for your own experiments, so you don't have to go through setting that all up yourself. And finally, DayPass, which I mentioned earlier, is a new feature. It solves kind of two general problems: one, sharing your work, and then two, if you're running these on Chameleon, it lets people who aren't Chameleon users or who aren't PIs or part of an active project, it lets them be able to run your experiment on Chameleon. And so if you package your experiment on Jupyter and share it on Trophy, you can enable a DayPass as an option for your experiment. And so with this, you'll get a link or a QR code. So for example, here's a QR code. And you'll be able to put those on posters or in papers. So these QR codes, this screenshot is taken from a poster that was at Supercomputing 2021. And so it was actually used at a supercomputing conference. And if someone is reading your paper or walking by your poster and is interested in your research, they can just scan it quickly with their phone, click the link in the paper, and it'll take them to this page where, if they aren't logged in, if they're a Chameleon user, or if they're just not a Chameleon user at all, you can click the button request DayPass. And so then that will send a request to you as the experimental author, and you'll be able to approve their request for like a short period of time. And then this will allow them to rerun your experiment using the exact same resources, using your code. And so it's really a big step forward for computer science reproducibility. And it helps make, static posters and papers more interactive. It can also hopefully help you get more visibility for your work. And maybe you'll find a new collaborator that way. But hopefully, it really encourages reproducibility in computer science, and is a very new feature that we're excited about. And so highly recommend checking that out if you're interested. And yeah, now we've kind of covered most of the content, what Chameleon is, how to get access to Chameleon, how to begin experimenting on Chameleon. And now another really important thing, how do you get help if you run into trouble? And then just kind of general help for the future as well. So as I mentioned before, we have very thorough documentation. You saw where it is on the website. There's also the FAQ, which is, I think, just below documentation on that drop-down menu. And then we also have the help desk, which you can use at any point in time. There's no paywall between you and the help desk. You can send them a ticket through the Chameleon dashboard or by emailing help@chameleoncloud.org. When you submit a ticket to the help desk, first make sure you've looked at the documentation and the FAQ. Don't forget, you can Google the documentation itself, so if you don't have to go poking through anything, you can just search your problem and put Chameleon Cloud. But if you do submit a help desk ticket, the fastest way to ensure that you get the help that you need is to include this kind of list of details. Make sure you specify what site you're running the experiment on, whether it's UC, Tech, etc. This will just help the ticket masters find your experiment faster. Also make sure to include the instance ID or the lease or a network, whatever is specific to your experiment. We need to know exactly which resources to investigate. And then it is helpful if you include what you expected to happen and what actually happened, and whether this occurred more than once. And if it did occur more than once, if in the past you tried anything to try to fix it, and what were the results of you trying to fix it. As well, it's helpful if you did install or run anything on the instance that may have interacted with the system, if you mentioned that. And if you're having trouble running an instance, the most important thing is do not delete it, please. If you delete it, it's gone from the system, so we can't kind of go back and try to pinpoint what was your problem. We won't be able to know what's going wrong. And there's no such thing as too much information. You can, copy paste outputs, just put it all in the help desk ticket. Even if you think it might not be useful, you never know, it could contain the solution to your problem. And a final note is to please keep us up to date on the status of the issue. Sometimes we understand you might be able to fix it on your own or find a workaround. But if that happens, please let us know, so we know just to archive that, and we can go and help another user. Yeah. And then so here are some helpful resources. I showed you where to find them on the website, but if you prefer direct links, here's some direct links to the documentation and FAQ. Additionally, the Chameleon blog might be of interest or helpful to you. We do monthly features of Chameleon users and their experiments, so you can look at that for inspiration. All of the researchers that I talked to you about previously were monthly features. So if you're interested in one of them, you can search for them on the blog as well and read a little bit more about them. And if you do an interesting experiment, we would love to feature you. There's also a monthly tips and tricks blog post that comes out, and it explains kind of how to use specific features of Chameleon. And at the end of the month, or at the end of the year in December, we publish a Tickets of the Year blog, which explains and provides answers to common help desk tickets that we've seen over the year. And so if you run into a problem, I also would point you to those blogs as well. You can find that by going to the blog and then hitting the tips and tricks section. And there are a lot of common problems that have been answered there. And so our ticket masters write those, and they provide the step-by-step solutions in those blog posts. Finally, here are some just general blogs that might be of interest, as well as how to use Chameleon. There is a blog, it's published, I believe, in September of 2021, and it has curated starter videos on YouTube. And so some of those small projects that I showed you earlier on Trovy, such as like the network and network experiment or the MNIST experiment, some of them have short roughly 5-minute videos explaining how to run them by the people who created those experiments, or like the packaged artifacts. And so you can go to that blog, read a little bit more about the experiment, run it yourself, and run it while watching the YouTube video. And so that's just another really soft kind of way to get started. And as I mentioned before, here are our upcoming webinars. We will have Science, Storage, and Sanity later today. It's kind of a deep dive into using the testbed and best practices. And so some of the tools that I touched on briefly will be covered there. And then tomorrow at 1 p.m., we have more about She at Edge, which is the edge computing platform on Chameleon. So if you're at all interested in edge computing or doing edge computing research, highly recommend going to that. And then at 3 p.m., we will have Practical Reproducibility with Chameleon, which is the Jupyter webinar that I talked about during this webinar. And so if you go to this bit.ly, you can see kind of a more in-depth description about each of these webinars and the link to register for these as well. Yes, and that concludes the webinar. But thank you so much for attending. We are on social media. We have a Twitter, a LinkedIn, and a Facebook account. All of those are at Chameleon Cloud. For Twitter, we post weekly tips And so those might be useful as you begin interacting with the test bed. They're just, very short little tips which could help you run an experiment or do something new and exciting. We also have a YouTube channel, which I mentioned briefly, Chameleon Cloud. A lot of our previous webinars are on there. There's the short 5-minute videos, which I mentioned. There's some user research on the Chameleon Edge testbed videos on there as well. And so if you're interested, if this piqued your interest for Chameleon and you want to learn more, you can check that out as well. And if there are any questions that pop up after this, you can reach out to us at contact@chameleoncloud.org, or the email for the help desk is help@chameleoncloud. Thank you very much. I can't see the chat if there were any questions that popped up, but if any come up in the future, you're welcome to email any of those places that I just said. Thank you so much for attending.